Apologies everyone for the glitch. So my name is Carlos Abellan. I'm one of the co-founders and the CEO at Quside. We're basically a company based in Barcelona, and our focus is around randomness technologies for two markets. So one is the cryptography market, including quantum key distribution. The other one is high performance computation. So I will give you some insights about the company. So the first one is our focus on randomness. So the thing is, most of the software that we use every day, it actually relies on having random numbers available. In the cryptography domain, actually, we rely on this randomness to protect information. And again, it includes quantum key distribution, but also most quantum key distribution schemes, but also post-quantum cryptography, conventional cryptography, symmetric encryption, many domains in which randomness plays a role. When we do not have good enough randomness, then we sacrifice the security of our communication. So being able to generate them predictable digits is of utmost importance. The other domain where we rely on randomness for a different purpose is on computation, right? There are many computational problems that are hard to solve, so we cannot solve them analytically. So we rely to what's called stochastic techniques to solve them. And in here, where you really care is about performance and efficiency. So you end up generating, processing, moving around randomness. And unless you do it efficiently and taking hardware into account, you may end up having inefficient simulations or even getting to wrong results. So at the end, the question is, are your random numbers good enough? And how do you know? And here's where we find limitations today. So being able to tell how good random numbers are in today's system is something hard or impossible to do in many instances. So who we are? So at Quside, we are a spin-off of ICFO. ICFO is a research center in Barcelona focused on photonics and quantum. We've been more than 10 years working on the development of advanced randomness solutions. And as we speak, we have two main photonic QRNG cores that we can produce wafer scale. One is on 3.5 on indium phosphide. You're actually seeing it on this slide. So this is a wafer of indium phosphide chips for quantum entropy generation. And I'll tell you a little bit more about them. The other technology is on gallium arsenide. And I'll also tell you why we're following those two material approaches. We've been working with customers all over the world and also establishing channel partners. One of the latest has been in Japan, where we have now local presence to distribute our technology. A team of about 45 people, above 60 patents, so very intensive on R&D and technology development, and VC funded. So we closed the Series A in 2022, and we're very proud with investors that are supporting our journey. What do we do? Our core technology is around entropy and randomness and quantum technologies. So we have these two technology approaches. The first one is what we call the QN100. Again, this is an indium phosphide chip. It's about 2 by 1 millimeters full area. It contains a couple of DFE lasers, a couple of photodetectors. This is all based on peer-reviewed research, and it can operate above gigabits per second. So in our own products, we're using these chips to generate a gigabit per second of random numbers. It can work even faster, not only in terms of frequency, but also in terms of the resolution of that sampling. So we can get even to tens of gigabits per second in sophisticated systems. And for the last 5 years, we've been producing wafers and refining our process. So we're ready for wafer scale manufacturing today. When I mean wafer scale manufacturing, I mean wafer scale production, from wafer processing to also packaging. And this is a gigabit per second technology, and this makes it very unique. What is the challenge is that some systems, if they don't need a gigabit per second of random numbers, this may be a bit of an overkill. So you get more than you need, and this is a waste of energy and performance. So we've been investing on a separate technology that we call the QV100, misleading name, so as a warning. So it's operating at 50 megabit per second. The benefit is that it's a lot simpler in terms of at the system level and consumes a lot less energy than the QN100 at a gigabit per second. So this is targeting larger volume applications in which complexity, integration, and power are very important elements. But in any case, on those two technologies, it's all about, from our side, on transparency with respect to the generation of entropy. So we feel today that in many instances, actually, it's even published on the report, that you do not get access to the quality of the entropy produced in chipsets, even in modern devices. We're pushing on performance because at the end in cryptography, you need good entropy in terms of quality, but also in amount. So we're producing solutions for a wide range of systems, from space and satellite, where we are actually part of several missions. So that means space engineering, also in terms of randomness, to IoT devices, where we will have some new announcements this week. Then What do we offer? We have 3 product lines at the moment. The first one is the entropy chips that I just showed you in the previous slide. So this can be integrated in the baseboard of any system. So we support the integration, and then you can just onboard that on your bill of materials. We also have quantum random number generators, modules, and systems. So sometimes customers, especially in low volume applications, they do not want to engage in the full engineering or integration of one of these chips. So we supply modules. This is the FMC. It stands for FPGA mezzanine card. So it's a plug and play system for FPGA developments. We also have PCIe Express, a low profile PCIe for both 100 megabit per second to a gigabit per second. And also appliances. We're starting to distribute appliances as well for infrastructure customers. And the third product line is what we call randomness processing units. And here we combine not only the generation of the randomness at the photonic level, but also hardware-specific acceleration. And that means several tasks that are required to be executed by a CPU, for instance, in a stochastic workload that we are offloading at the hardware level. And by doing this offloading, we actually get significant efficiencies in terms of power, but also in time. So in finance, for instance, it's typical to see in Monte Carlo simulations speed-ups of 10x in terms of time and 20x in terms of energy. So what are we looking for, and where we may be able to partner or help or support? So we identified a couple of areas following Ivan's request. The first one is we would like to support your randomness needs, right? So if you need randomness generation in your systems, from megabits to gigabits, we're ready to support. From space systems, which is one of our most important markets at the moment, to ground systems, we're also ready to help. In form factor, from chips to appliances. So again, we can also adapt to a wide range of requirements. And in the applications, cryptography and compute. These are the 2 domains where we would like to work with you if you need this sort of technologies. The second one would be more on the R&D collaboration space. And in our case, it can be either on the scaling side in semiconductors, developing European supply chains and bringing as much of the production as possible to Europe. This is an area where we're happy to collaborate. This can mean, for instance, in a consortia or a project that we are an end user, right? We are a fabless company, but we can be a user of these technologies in terms of photonic manufacturing, photonic assembly, packaging, testing, wafer level stuff. So both as a partner in innovation and as an end user, we're happy to join initiatives. And then also collaborations in building quantum safe security systems for both space and ground. So in those arenas, we're typically engaging with customers, with partners across Europe, and we'll be more than happy if you're thinking about some of those initiatives to join you to explore possibilities, both again as a partner or as an end user. With that, I'll be happy to take any questions or comments from the audience. Thank you very much.